on and we talk about proportionality intercept theorem, right, I just wanted to be able to quickly fit in what I wasn't able to do last time. Okay, so I just want to do one question here as an example with you, and then we can go on and carry on talking about, just going to move that one out of the way. Okay, and I just want to make this a little bit bigger. Just get rid of that. Okay, so this is what I wanted here in the middle of the screen. Hang on a second. Yes. Things don't cooperate. Okay, I hope that is big enough. There we go, because I wanted you to be able to take a screenshot of this. Okay, so just very, very quickly, I want to go through this example, which I didn't manage to finish last time. And that is if we want to prove that quads are cyclic, okay, because this is something that's always going to be asked of us. So these are the converse theorems. Right, we have to use the word converse. I'm going to explain to you what that means. What's important for us here is number 1, number 2, and number 3. These prove that a quad is cyclic. Right. So if I can prove that angle A plus angle C equals 180, they're not necessarily equal to one another. So let's just do something different here. Or if I can prove that angle D plus angle B equals 180, then I've proved that this quad is a cyclic quad. All right, so here by doing that, I would use the reason converse opposite angles of a cyclic quad. I can also prove that a quad is cyclic if I can prove that the interior angle is equal to the opposite exterior angle over here. So if I can prove that's supposed to be B, if I can prove that angle A equals angle BCE, then I can also prove that DABC is cyclic using converse exterior angle of a cyclic quad. And I'm going to show you an example of that now. And then the last way that I'm able to prove that a quad is cyclic is to use converse angles in the same segment. So in other words, if I'm able to prove that angle A equals angle D, or if I'm able to prove that angle B equals angle C, then I can prove that ABCD is cyclic, or that ABDC are concyclic points. Right, so I just want to show this to you. All right, here's an example of how we would do this. Okay, so if we have been given KLMN, which is a cyclic quad because it's got 4 points on the circle, and KM and LN are joined, T and S are points on LN and KN respectively, such that KN is parallel to TS. Prove that LTSM is a cyclic quadrilateral. So if we go and highlight LTSM, there's line TL, there's line TS, there's line SM, and there's line LM. There is our quad, right? Now, the reason that it's not cyclic at the moment is because there isn't a circle that has been drawn through those 4 points. So when you are proving that a quad is cyclic, you are proving that it's possible to draw a circle through its 4 points. That's what you're doing. Okay, not that there necessarily is one there, but it's possible for us to do so. All right, so KLMN is a cyclic quad because there is a circle drawn through KL, M, and N. All right, so when we prove that LTSM is cyclic, we're proving it's possible to draw a circle through T, L, M, and S. Can you see that inside this would-be cyclic quad, okay, inside this quad, there is no bow tie. There's no bow tie inside. So that means that using reason 3, converse angles in the same segment, is not going to work. So we can't use that. All right. So let's try the next best one. So if possible, if you see a bow tie inside, try converse angles in the same segment. If that doesn't work, then try converse exterior angle of cyclic quad and use converse opposite angles of cyclic quad as a last resort, because that's the most difficult. So now if I have a look at this quadrilateral has an exterior angle. There's an exterior angle at S1 and there's an exterior angle at T1. And in this case, it doesn't matter which one of these I use. So let's say I decide to go with angle T1, which is an exterior angle to this quad. If I can prove that T1 equals which angle inside the quad, then I've proved that the quad is cyclic. What does T1 need to equal to prove LTSM cyclic? It needs to equal which angle? That's it, Amina. Good job. Okay, it needs to equal M1. Okay, so if I can prove that M1 equals T1, I have proved that the quad is cyclic. Okay, so now I can't assume that that's true. This is what I'm trying to prove. So I'm going to rub that out because I don't know that it's true yet. So what I need to do is I need to find the link between T1 and M1. There is another angle or another couple of angles inside these circles that is going to help me to be able to do this. So what else does T1 equal? Remember, we have parallel lines. What else does T1 equal? Again, you can pop it into the chat. Remember this line over here, TS, is parallel to this line over here, KN. What does T1 equal? There we go. It equals N1. Good, Chloe. Okay, T1 equals, good stuff. Okay, so T1 equals N1. Our reason for that is alternate angles because KN is parallel to TS. So if there's anybody that's struggling to see that at the moment, oh, hang on a second, let me just make that a bit bigger. That, have a look at this. Okay, so here is KN. We've got this diagonal line over here, and there is T1. Can you see that T1 and N1 are alternate angles? That's why they are equal. So now that we've established something else that T1 is equal to, let's just see if there is a link between M1 and N1. Is there a link between M1 and N1? There we go, Katleho, beautiful. Oh, Chloe, you also said it. Excellent. So there we go. We found our connection. All right. N1 is equal to M1 because of angles in the same segment. Excellent. Okay, so N1 is our bridge. It is our link between T1 and M1. So if T1 equals N1 and N1 equals M1, we can now conclude, and this is very important to do so because we're going to get a mark, that T1 and M1 are equal. And because T1 and M1 are equal, that is what makes LTSM cyclic. So it is cyclic, and our reason here is converse, exterior angle of a cyclic quad. Okay. All right, so that is quite simplistic, but it conveys the point that I'm trying to make quite clearly. Okay, are there any questions? Are we all good?
Wow, guys, well done. No
Thumbs
questions.
ups. You sure there's no questions? Okay, so now again, I'm going to give you a question for homework. I'm going to give you this one. I just want to make it a little bit bigger so that you guys can take a screenshot of this particular question. All right, so here, if you are able to prove questions B, C, and D, that's wonderful. I will provide the answers for those next time as well. But what I want you to do is part A. Okay, so proving MTAR as a cyclic quad. Once you've obviously read this information, you should be able to do the rest of these as well. I encourage you to get that done. But at the very minimum, I want you to try and prove that MTAR is cyclic. Okay, and then what we're going to do is move on and start talking about the metric stuff. Okay, so go back. Somebody wants to take a screenshot. There you go. So I think that was because of question 5. Okay. And then over here, screenshot of this, 2.3, you're going to do this question. Okay, so Lutando, a segment is a part of a circle, right? So in other words, if you have a circle and you have a chord, okay, this piece over here is called a segment. In this case, we would refer to this as the minor segment because it is the smallest segment of the circle. This bit over here, and I'm going to highlight it in green for you, what's left? Okay, this bit over here, that would be referred to as the major segment of the circle. So a segment is a piece of a circle. Okay, it's created by a chord. All right. So yes, 2.3 is your question. Okay, for next time. All right, on this particular section. All right, so you guys wanted questions to do. So there's this, and then I'm going to give you another one on proportionality that you're also going to do as well. So there's a little bit of work here for you. All right. No problem, Naledi, welcome. All right, so what I'm going to do now is I'm going to jump into, because this is grade 11 work, I'm going to jump into the grade 12 work, right? And the first theorem that you learn about in matric is something called the proportionality intercept theorem, right? And the proportionality intercept theorem states, and again, use screenshots here, it states that a line drawn parallel to one side of a triangle divides the other two sides proportionally. Now, I want to show you exactly what I mean by that, right? We have triangle ABC. The line drawn parallel to the one side of the triangle is line PQ. So this line drawn parallel to one side of a triangle is PQ because PQ is parallel to BC. It divides the other two sides into the same proportions, right? So it divides the other two sides into the same proportions. Okay, so the other two sides are sides AB and sides AC. Those are the other two sides. Okay. Now, when we say that something is cut into the same proportions, what we are doing is we are saying they are not necessarily the same length, all right? So if I say to you that the length of AP is 3 units and the length of PB is 2 units, then AQ and QC are cut into the same proportions. So maybe AQ is 6 units in length. If it was, then QC would have to be 4 units in length. So they are in the same proportion. That is because 3 over 2 is the same as 6 over 4. That's what we mean by they're in the same proportions. Okay. Is everybody happy with that? Does that make sense? So this statement over here is referred to as a proportion. Okay, and it states that one fraction is equal to another. Remember, it does not mean that the numerator here equals the numerator there, because it doesn't. And it does not mean that the denominator here equals the denominator here, because it doesn't. They're in the same proportions. So in other words, when I go from 3 to 6, I'm timesing by 2. Just like when I go from 2 to 4, I'm timesing by 2. They are in the same proportion. Another way of looking at that is that 3 is to 2 is the same as 6 is to 4. Is everybody happy with that? Does that make sense? Thumbs ups? Thumbs down? Or how are we feeling?
Let's vote, my people, so we can know where we are. But at least
Does
they
make
have
sense? Okay. All right. Okay. Cool beans. So the one of the conclusions that we can reach, and there's more than one conclusion here, but one of the conclusions that we can reach is that if we put AP over PB, okay, so AP is this bit over here, over PB is that bit over there, it's going to be the same as the proportions on the other side. So in other words, as AQ over QC. So it's exactly what I've written here. AP was 3 over PB was 2 is equal to AQ over QC. All right, so that is the conclusion that I can make. And when I do this, the reason that I use is the proportionality intercept theorem, which I'm allowed to abbreviate. I can write this as proportionality intercept theorem. And because this theorem exists, it only exists because there are parallel lines, because there's one line drawn parallel to the other side of a triangle. So I have to state the parallel lines, just like when I'm working with alternate angles or co-interior angles or corresponding angles. So I must name the parallel lines. So PQ parallel to BC, like so. Okay, so let me give you an example of how we use the proportionality intercept theorem. This is the theory behind it. Let me show you how it gets applied. Before we do that, I just want to show you the other proportions that we can write as a result of this diagram, because AP over PB equals AQ over QC is not the only proportion that I can write. And the reason for that is because I can play around with these numbers. All right, so if you have a look here, I said that 3 over 2 is the same as 6 over 4. Okay, what happens if I change 4 and 3 around? So if I say 4 over 2 is 6 over 3, is that still true statement? Is 4 over 2 the same as 6 over 3? Yes, it is. Okay, so I'm allowed to interchange a numerator and a denominator because it still makes mathematical sense. Look here, I can also do this on the other side as well. So I interchange 4 and 3. I can interchange 2 and 6. So if I write 3 over 6, so in other words, I'm putting 6 where 2 was and I'm putting 2 where 6 was, it's equal to 2 over 4. Is that okay? Does that make mathematical sense for me to do so? When you say Amina, how though can you explain that? What do you mean exactly? Sure, Amina, go ahead and ask a question.
So ma'am, I don't understand. You put 3 over 2, okay, that's what we have, and then 6 over 4. And then you take the 4 and you put it over the 2, and then the 6 over the 3. That's why I'm getting confused.
Okay, so in other words, what I'm doing here is I'm working from this. Okay, this was my original statement. Okay, and I'm interchanging 4 and 3. So I'm taking 4 and I'm putting it where 3 was, and I'm taking 3 and I'm putting it where 4 was. So 3 and 4 swap places with each other.
Oh, and it doesn't change anything about like the theorem.
No,
you can still use
absolutely. Absolutely, because 4 over 2 is the same as 6 over 3, isn't it? Because 4 divided by 2 is 2, and 6 divided by 3 is also 2. So I can make another proportion using the same 4 numbers, but I'm just changing the proportion that I'm making.
Oh, and
okay, so I am manipulating my proportion and I'm creating other proportions. Does that make sense to you?
Yes.
Okay, all right. And then I did the same thing in the second instance here as well. So that's the first manipulation. Then I did another manipulation. So the first time I interchanged 3 and 4. The second time I interchanged 2 and 6. So in other words, all right, I took 6 from the top here and I moved it down to where 2 is. And I took 2 from the bottom and I put it up where 6 is. All right, so that's what I did. Okay, so here these two have interchanged places with one another. And can you see my proportions still make sense? Because 3/6 is the same as 2/4. That's why I am allowed to do these manipulations. All right, provided that what I'm writing still makes mathematical sense. All right. Okay. So, other proportions that we can make. So let me do the first one with you and let's see if you guys could maybe do the second one on your own. So again, we're looking at the same diagram that we were looking at earlier. All right. So this diagram over here, I'm just clearing this out the way so that it's a little bit clearer. Okay. AP. So now what they've done is they've taken AP. So AP is this side over here. Okay, and they've put it over AB, the whole side. So in other words, that whole side. Who can do the same thing on the other side? What should I have in the numerator on the other side? You can pop it into the chat. Okay, so there we go. iPhone's got it. Yes, Rona's got it. Quite right. Well done. Okay, so AP is going to have AQ at the top over here over the whole side, which was AC. Very good. Well done. Okay, so that's another proportion that I can make. Good. Excellent. Well done, everybody. Let's see if you can do the second one on your own. So PB over AB. So again, this is the diagram that you're working from. So PB over AB is the same as, that's it. Well done. You guys are smart. Lovely. Very nice. Is the same as QC over AC. Excellent. Very nice. Okay, you are manipulating beautifully. Good, 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 good. Well done. Right, now the last one is a little bit more difficult. Not much, but a little bit more difficult. So we've got AP at the top and we've got AC at the bottom. Okay, so what goes in the missing spaces? So what goes below AP?
Amina's hand is up. Amina has not to answer.
All right, Amina.
I wanted to answer AP over AB and then AQ over AC.
So sorry, you just wanted to give an answer.
Yeah.
Okay, so just say your answer again, Amina.
AP over AB.
Over?
AB.
AB, okay, so over the whole thing, all right.
And then AQ over AC.
All right, that'll work as well. Okay, so AP over AB is the same as AQ over AC. All right, lovely. Okay, very good. Okay, nice. Well done, everybody. That is perfect. Okay. Now, the next thing that we are allowed to do, let's just continue our conversation here with these proportions, is this. If I gave you an equation and I said to you that, let's choose a different color, let's go with orange. If I said to you that x over 6 is equal to 2/4, what method would you use to solve this equation? There's a method that we've been taught at school from grade 8. Katleho. That's it. So, Katleho, what would you do?
Ma'am, what if you just divide the two and then you see the ratio and then you like times the 6 with the ratio, ma'am, because they have the same ratio. Like the
They
same
do. They do. But you know what the easiest thing to do here is, a lot of people have said it in the chat as well, and this really is the easiest thing to do, is for you to cross multiply. So in other words, you would say 4 times x is equal to 4x. And here you would say that 6 times 2 is equal to 12. And then you would divide both sides by 4, and you'd work out that x was equal to 3. We are allowed to do the same thing with our proportions. Okay, so if we go back and have a look here, if I cross multiply, so in other words, if I multiply 3 and 4 together, I get 12. If I multiply 2 and 6 together, I also get 12. So I'm also allowed to cross multiply my proportions. Okay, in the same way over here, 4 times 3 would give me 12, and 6 times 2 would give me 12. So you are allowed to cross multiply. So if you have got a proportion, such as this one over here, where you've got AP over PB is equal to AQ over QC, you are allowed to cross multiply. That means you're multiplying AP with QC, and it will be equal to PB multiplied with AQ, like so. Okay, that's it. Okay, 100%. Is that making sense to everybody, where I can cross multiply? Are we thumbs ups at this point for number 2? Is it Kiana? Kiana?
Well done, guys.
Good, well done, everybody. Kiana, you're welcome to unmute and ask. Okay, so Kiana, I don't see or don't hear you. If you're not sure, that's fine. We can come back and we can take a question later. All right. So what I'm going to ask you guys to do is to cross multiply. Let's apply what we've just seen over here. I want you to do it to this one. I want you to cross multiply and write the proportion as a product. Okay, so the one that I've put the blue box around, write that proportion as a product. And then you can pop in the chat what you've written. Because, Rona, we have to be able to understand how proportions work in order to be able to get to the real stuff. Trust me, this is going to get very difficult. Okay, so we need to understand the basics before we can jump in. And not all of us are as fast as you. Okay. So how would we write that as a product? That's it. So PB times AC equals AB times QC. That's it. Okay, so Yanela, Ola, Chloe. There we go, guys. Excellent. Okay, so you've written it as a product. Good stuff. Well done, everybody. Okay, let's move on. This was just going to give you a little bit more practice with writing the proportions, but I think you guys are doing okay with this. If we're not, we can always come back to this. Let me then go and show you how we would apply this. Okay, so here's the first example. Okay, so we have been given a triangle, the same triangle that we've been working with, and they've told us that AB is 12 centimeters in length. Okay, so this entire side over here from A to B is 12 centimeters. FB, this little bit, is 3 centimeters. GC is 14 centimeters. I'm going to write that in a different color. This is 14 centimeters. They want us to calculate the length of AG. So the first thing that you need to do is you need to make a proportion, and you have to substantiate your answer with a reason. Okay, so in other words, proportionality intercept theorem. So we know that we're allowed to apply proportionality intercept theorem here because we have a line drawn parallel to one side of a triangle, and it cuts the remaining two sides in proportions. So the easiest thing for you to do is to put AG in the numerator. Okay, we're going to make a statement because we want to solve for AG. All right, so here is my proportion statement. Okay, if I say AG, oh, by the way, let me just ask another question. If AB is 12 and FB is 3, how long is AF? How long is AF? Put that into the chat. How long is AF? AF is 9. Good. Okay. So if I take AG and I put it over GC, what is it equal to on the other side? Which side over which side? Put that in the chat. So AG over GC is equal to what? By subtraction, Sipang. Do you have to write proof for AF? No, we don't. All right, so we're allowed to say that 12 minus 3 leaves us with 9. We don't have to write a proof for that. So on the other side, you're saying AF over FB. Okay, so AG over GC is AF over FB. Good, well done, equals AF over FB. Reason, proportionality, intercept, theorem. What mustn't I forget to do? Name the parallel lines. So FG parallel to BC. Now I can go and substitute. AG is what I'm solving for. GC is 14. I know that AF is 9. FB is 3. Now you're doing exactly what I was showing you, except I used an X. You are cross multiplying and then solving for AG. So in other words, 3AG is going to be equal to 9 times 14. 9 times 14 is going to leave me with 126. And then I'm going to divide both sides by 3. And I'm going to work out that AG is 42 units, like so. Okay, so that is how a proportionality intercept theorem is applied. Okay. Good, well done, everybody. Okay, 42 is correct. So again, take a screenshot of this. And now you guys are going to practice this idea a little bit. Okay, all right, so I'm going to move on, right? And I'm going to give you these two questions over here. All right, so there's just a little typo here. This says calculate the value of y, it's x, here's x over here. So if you are feeling confident, Rona, you can do 1 and 2. If you're not feeling too confident yet, maybe just do the first one. Okay, so let's try 1 and 2. And if we get that right, we can move on and have a look at some more questions. I'm going to give you guys 5 minutes, and then we will reconvene and talk about our answers. Oh, wow, you guys are super fast. Well done. Yes, that's the correct answer for X. We just got to talk about your setting out just to make sure that that's perfect. All right, but that's great. Well done. If you've done that one, try number 2. Good job, everybody. Great work. Very nice. Well done. Okay, so Lorato is already finished. Good job. I just want to check that you guys are setting this out correctly. So here's the answer to number 1. Okay, so statement, reason, cross multiply. So 5x is 20, so x is equal to 4. Very good. All right, let's have a look at what the others are saying. All right, so you're all saying that y is equal to 15. So over here, maybe what you did was this, where you said y over 35 is equal to 18 over the sum of the side over here. So 24 and 18. So 24 plus 18. Again, write your reason. Don't forget to name the parallel lines. So BD parallel to AE. And again, we're going to cross multiply. So if we add 24 and 18 together, we're going to end up with 42. So that means we've got 42y is equal to 18 times 35, which gives us 630. Divide both sides by 42. And as you guys had said correctly, y would be equal to 15. Okay, so you have to make the statement and you have to provide the reason. Okay, in geometry, we make a statement, a reason, and then we do our solution. Okay, same story here. Statement, reason, answer. In matrix, they are very fussy, all right? If you use proportionality intercept theorem and you don't name the parallel lines, you will be penalized. Okay, so very important that we're setting it out the correct way. Okay, so Amina, what are you confused about with the second bit? Okay, maybe Yolanda can help you with that. All right, I'm going to move on for everybody else. All right, so you've got a screenshot of that, Amina. You can ask Yolanda. All right, now you can try this one, try number 3. Make it a bit bigger. Sorry, guys. Okay, Rona, I know you are a fast finisher. Just going to move this stuff over.
Okay, Amina, I have answered you on the chat, and I see Lutando is also confused about the second one that we did. I think it's because it was a little bit different than number 1. Then everyone is a little bit. Don't panic, though. You'll understand. I'm explaining it to you on your private chat.
Okay. Okay, so you guys are getting Emma's 4. All right. Let's try questions 5 and 6. I'm just going to put up the answer to 3 behind the rest of you. Good. Well done, Katlego.
Would it be okay if we go back? It's just Lutando needs to take a screenshot. Sorry, Teacher Leah.
No, that's fine. Where you, Linda?
On number 2. So on the previous screen, it just needs to take a
Oh, there you
screenshot.
go. Screenshot. There you go.
Take screenshot, Lutando, and I think it was Amina. There we go. Thank you so much, Teacher Leah.
No problem. All right, Katlego's already got answers. Well done, Katlego. You can move on to the next one. Mina, would DG be equal to 20, you said? So yes, 20 is the correct answer, quite right. DG would be equal to 20. You guys are correct. Okay, so Lorata's putting an answer for GE here as well. Let's see what you got, Lorata. Yes, GE is 12. You guys are right. Good. Excellent. DH is 15, that's quite right. Good, well done. And then I see some of you, HF is 9. Well done. Yes, lovely. Good job. Well done, everybody. Very nice. Anybody been able to work out the length of PT in question number 6? All right, so we don't have an awful lot of time left. Okay. We don't, okay, so maybe what we can do for those of us that are finished, all right, you can try question 6 for homework, okay? As far as the steps of question 5 are concerned, yes, absolutely, I'm more than happy to explain that to you. Now, they've told us that DG is to GE is in the ratio 5 is to 3. So this GD and GE are 5 is to 3, okay? So if they tell us that the length of DE is 32, what that means is that line DE has been cut into 8 equal parts. So in other words, so this is like sharing in a given ratio. So in other words, DG represents 5/8 of the length of DE. So 5/8 of 32 would give us 20. All right. Similarly, GE would be 3/8 of 32. All right. So that's why it is 12. So we didn't necessarily need proportionality intercept theorem in order to be able to do that. Then when they asked us for DH, all right, we know that DG over GE is equal to, what have they given us? D, okay, so we know over here that this entire side is 24. Okay, so in the same way, all right, we're working with proportion. All right, so in other words, 5/8 of 24 is where 15 comes from, okay? And similarly, 3/8 of 24 is where the 12 comes from. So 3/8 of 24 is where the 12 comes from. So this is actually sharing in a given ratio. All right. That's okay. It's also good to sometimes have to struggle with something. Okay, so don't feel put off by that. Okay. All right.
Ma'am, can I ask?
Yes, Kakleho, sorry, go for it.
Ma'am, you see number 2, ma'am, which is number 5. They say DG is to GE equals to 5 is to 3, ma'am. So, ma'am, what if I added 5 and 3, ma'am, and it will give me like the equal parts that they divided DG, ma'am?
Oh, absolutely. Okay, so in other words, if you add the 5 and the 3 together, that's why I am dividing by 8. Okay.
Yes, ma'am. Okay, ma'am. Thank you.
Okay, that's why I'm dividing by 8. Okay, so DG is 5/8 of DE. Okay, that's quite right. Okay, all right, so we're going to do number 6 for homework as well. All right, doesn't matter if we struggle with it, and then I'll put the answers up to that next time as well. Okay. All right, so that means it's time for us to go and do the quiz, and Yolinda's going to pop that into the chat. Ola, go for it. If you have a question, please ask. Did I make a mistake somewhere? Yes, Ola.
Ma'am, excuse me. May you please go back for yesterday's corrections for yesterday's homework, ma'am.
Okay, all right, I'll show you the answers. That's fine, that's not a problem. It was over here. There we go. So that was yesterday's homework, was this bit here.
Thank you, ma'am.
No problem.